Yeah, so let's get over what we have done till now. So first of all, major thing, we need a circuit to control everything. Before that, actually we should go with the base. Yeah, so first let's talk about the base. So for the base, as I told, it was a simple project. So we just need a caster wheel and two motors to control it in a differential drive mode. But a differential drive, basically to move the board forward, both of the wheels move forward and caster wheel support it. To move the board backward, both of the wheels move backward, caster wheel support it. To move the board right, we just move one wheel forward, other wheel backward, and it just move in one direction. If we do the same thing vice versa, it will move in another direction. Simple as that. And caster wheel is like a two-axis wheel, so it can move in any direction. That's the point. Yeah. So this is the basic part of the board. Now with that said, I have built one thing on it, that is this sensory part. Okay. So what this thing is, basically we have put IR sensors here. What this will do it will emit a light. This receiver end will receive the light. Similarly here, it will emit the light, receiver end receive the light. I did nothing, I just used a soldering iron to poke hole into this, to screw this in and to screw that in. Yeah. And here is the circuit. Okay. And with that said, what I have done, one thing here was, like if you just go with this, okay, sometimes you need to go from the scratch part to understand the things on their basic level. Okay. So what is an IR sensor? IR sensor is not a distance sensor or not an optical detection. It's basically a light emission and a light detection. Simple as that. Now what I wanted was, I was low on resources, so instead of putting three sensor, like one for right, one for left and one for forward, what I did was I make it like this way, like a slant way. With that, at a diagonal point, what will happen is I can detect the left side from the forward direction. Okay, so I can also detect the forward plus the left. Same way I can detect the right plus the forward. Understandable, very easy. Now with that said, I have done one thing more. I have put these walls here. Why? Understand this. This is a light. Okay, so light source, what happened was, what this thing does is, you emit a light, it receives a light. Okay, now what happen is, when there is something down it, okay, something below it, what will happen is the emitted light will bounce off that surface and project it onto this sensor. With that, what will happen, our sensor will detect it. It's a obstacle, okay, it have a surface below it. Now what I wanted to do here is, if you can understand, let me start first. If you can understand a little, see, what will happen is, if I put it like this way, so when an obstacle goes below, previously when I have not applied this, what happened was, when an obstacle is almost at this area, only at that point this light goes like below, and like there is not a surface below beneath it. So what will happen is, light just go forward and does not get received by the sensory part, in receiver part. With that, we have detected that there is no space to go forward. But at this point, as you can see, the wheel is almost at this place that it can skid down very easily, because it will have a weight over here, so it can just skid down. So to improve that, what I did over here is, I put this a cardboard piece to block the light. Now what will happen is, with that, only this light will only be bounced when there is an actual surface beneath it, not while, okay, at previously it was also doing that thing only, but there was a difference. Like it have like now, if I can explain it a little better, basically now what's happening is, at the point it just leaves the surface, we can detect now. Okay, so basically it can detect, it's not bouncing at this direction now. At receiver end, it's not bouncing any light. So what will happen is, as soon as light crosses, this is at a diagonal direction, slant direction. So what's happening is, as soon as the point leaves the surface here, okay, as you can see, the light can directly go beneath, directly past the surface. No surface is there to stop the light. So the light will not bounce off, and we will have a stoppage here, and we will still have a surface for the caster wheel to support it. With that, what will happen is, we can just make our board instantaneously turn backwards, right or left, whatever the cases we have feed into the board, and with that it can just move backwards. Yeah, that was the simple analogy we are trying to do here, a simple structure we are trying to perform here. Okay, with that we have a basic sensors of a board and a basic body for the board, and this is the most basic body you can build with the sensor inputs to make your board a usable board without falling off anything. Okay, now this will be our desktop board. With that, this part has been done. Second part was the circuit part. Now for the circuit, I have built this part, so I have explained it already. So what I have built over here for the circuit is, I am using an ESP 12V. Okay, so it's a cheap sensor. I already have cheap microcontroller. I already have it. I soldered pins to the jumper pins, and with that now it can be just used as a normal board. And to program it, I have also made a custom programmer. You can get the pin diagram for the programming, but yeah, I can just show you here what the programmer. Just a sec. Yeah, here it is. So this is my custom programmer. You can just put your ESP onto this, and you can just put it into programming by clicking this and resetting, and it will just get into the programming mode, and then you can just upload your code into this and then just take it out, place it in the board, and you're good to go. So this is the basic circuit. Now what the circuit does is, these are our the sensor parts, and these are all the sensors and servo controlling pins will be connected over here, and motor driver is directly connected here, with the gyro also directly connected to here. So we can just take our gyro. I have used the long jumper pins to make it actually to make it compact basically, and I in this part, motor driver part, I have taken two long jumpers, so that I can just put it directly on above it. Okay, one thing I did over here is I used let me just remove first this thing. I have used a servo on top of it, so that I can get the length also. At the same time, this thing also work as a support for me. And what I did was, I used a soldering iron to tweak a hole into the servo motor's plastic area here. It have a small space where I just put a hole. I first have to unscrew this, put the hole into the plastic, then there I put a screw it down here, then I screw this whole servo back in. With that, I have just attached the servo to this thing. Now, even if the main purpose to make it modular was to if the motor driver any day get get bad or something like that, so it burned or something, so we can just replace it. Okay, we can just remove it and replace it. Yeah, you need to do some soldering again and again, but okay, fine. And the servo can be just screw out and screw back in the next L290 motor driver. Yeah, that being said, this is done. So yeah, and this will just plug it. You can just plug it here. Yeah, that's how it is. Then I have the servo joint. So basically this is the servo joint you get with it. So what I did, I have this old screw with me, which is a hollow screw. Okay, you can get it from the market or any screw market. Okay, make sure why I taken this screw is basically it's used for this thing. This is a phone holder. You can get it for 50 rupees online or anywhere. Basically, it will hold your phone. So now with this set, I am using my phone. So this screw can directly fit into this thing. So we can just rotate it and put our phone onto it. See? Yeah. Let's rotate one more. Yeah. Now. And we can attach this directly onto the servo now. And because this was a metal screw, I have just placed the iron on top of it. Like, okay. First you see the part. Yeah. Now with that, it can just move our phone up and down, just like that. And that being said, let's remove it. Here is what I did was, I just put, this is a hollow screw, so I just put this soldering iron here. It hottened it enough. It hottened up the screw enough to melt the plastic down and get inside the screw and just stuck there. And I also put the fabric on top of it, so that it could be a solid joint and our phone doesn't fall off. Okay. That said, everything is done. Now, yeah, this is the part till we have reached till now, and yeah, so I can just all this button done, and we can just use yeah, and this is a basic battery pack. Okay, I have used a BMS to make it rechargeable and to not basically damage our batteries by over discharging and overcharging it. So yeah, this thing is done, and we can just put it on top of it. And for putting it on top of it, what I'm using is, I'm using its case only, and on that case I have make some cuts to make it fit over here. So let me see, like it can just slide it in. Okay, so if we just slide it in, yeah. So I put the cases to hold this part, okay, motor part, and also the wiring will be going from here only. So yeah, now this way we have a very nice base. With that, we have a good circuit, and we can just put this circuit on top of it and replace it any day if it gets damaged or anything. And the battery packs also, yeah, over here, something like that. Yeah, and this will be our bot. I need to join it together, but yeah, you get the basic understanding, and you can just move forward, and it will be your bot. Yeah, I guess this is done. So we can just go on, move it, join it, and let's get back with the working prototype now.